Hey folks, Dr. Duncan here, continuing with our introduction to sea level rise, the trends, impacts on people and biodiversity, and adaptations. What we're going to talk about next is how sea level rise contributes to the increased destruction that we're seeing along our coasts due to hurricanes. There's a strong connection here, and one that leads to a lot of impact in terms of affecting people's lives and economies along our coasts. So first of all, what is a storm surge? This is a term that I grew up with and didn't realize that folks that don't live along the coast might not have any idea what we're talking about when we say storm surge. When large storms come ashore, you wind up having extra high tides come ashore because for a variety of reasons, the principal one being that the winds from the storm drive and or push a lot of water up against the shore. And that extra amount of water on top of whatever your tide is at the time is going to be what we call the storm surge. And usually it's that storm surge that is able to overtop barriers like dunes or walls or other things that we have in place that typically keep your average tide from infiltrating the human-built environment. Now, let's talk now about hurricanes. Hurricanes, of course, bring a lot of the worst of our storm surges to the coastlines, although we can get storm surges with minor storms as well. But hurricanes, a couple things to learn about hurricanes. Hurricanes in the North Atlantic have not become more frequent when you look at the overall history of hurricanes in the Atlantic going back to roughly around the year 1900 or so. That said, we have seen more frequency or higher frequency of hurricanes in the North Atlantic since the 1970s. We're just not sure yet if that is going to be a continuing trend or not. And I'm sorry that the little graphic there covers up the wording there. It says hurricanes in the North Atlantic have become more frequent since the 1970s. Now, if you pay attention to what happens with hurricanes simply by listening to the news, you might have missed out on that because for a long time since the 1970s, our hurricanes were being steered by upper level winds out into the Atlantic. So they weren't hitting the U.S. coastline, but they were still out there, and they do count as part of our hurricane frequencies over time. Now, hurricanes, while they have increased in frequency since the 1970s, but we're not sure if that's the long-term trend or not. For sure, hurricanes are causing more destruction. Now that's in part because more people are living along the coasts. That's obvious. If we put ourselves in the path of hurricanes more than we did in the past, then well, yes, we're going to have more destruction as a result of hurricanes. But we're also seeing, as measured by satellites and other instrumentation, we're seeing that hurricanes are larger, that the winds are stronger, that they're moving more slowly than ever before, and they're delivering more rain. And then the last part there that you see on the list is that they're bringing larger storm surges ashore. So all 5 of those components contribute to the destructive force of a hurricane. And all of them are enhanced by climate change because hurricanes feed off of warm water. That's how they get their energy. And as the oceans warm up, hurricanes have been getting stronger and stronger, or more intense and intense, however you want to think about it. So that bottom line there, that fill in the blank, is the relationship between sea level rise and hurricanes is that sea level rise makes storm surges worse. Now, we've seen some dramatic impacts of hurricanes in just the last couple of years. This is a picture from Mexico Beach in the Florida Panhandle just hours after Hurricane Michael struck in 2018. Pretty much devastated this community of Mexico Beach. This is Hurricane Harvey that hit Houston in the year 2017. Not so much damage from shearing winds and so forth. It was more the damage caused by the flooding. You had the storm surge moving ashore, coupled with an intense amount of rain as the hurricane sat on top of sat on top of Houston and rained and rained and rained on a city that already has a very is already very close to sea level and doesn't have a lot of capacity to absorb a lot of floodwater. The economic costs here are huge, as are the toll in human lives. As you see here, some of the more recent hurricanes, they cause billions, tens of billions of dollars worth of damage to these communities that they hit. But they also claim lives, and that's probably the more tragic part of all these statistics. All four of these storms, which were major headliner storms, killed a total of 306 people. In addition to those storms, there have been another 18 additional hurricanes striking the southeast since the year 2000, each of them causing over $1 billion in damages. The southeast is particularly vulnerable to flooding as a result of these storm surges and hurricanes because much of the region is at low elevations and we have high concentrations of people along the coasts. So this is one way that sea level rise is impacting the southeast, our culture, and our economy. But there are other ways as well. Let's explore some of those. Some of these have been referenced in the videos that you've watched so far as part of this exploration of sea level rise. One of the things I want to focus on is what's called saltwater intrusion. This is illustrated by this cartoon where you see on the left what happens in normal situations where you've got your land surface here, and right here would be the coastline, and here's your ocean out here. The dark blue here, as well as the light blue here, is all land. That's basically soil, sediments. And ordinarily, the waters from the ocean infiltrate the sediments of the land or the soils beneath them, and that's represented by the dark blue here. That's salt water. Whereas over on the land side of this illustration, you have fresh water in those soils. And so this line right here, this dark blue line between the light blue and the dark blue fields represents that transition between the fresh water and salt water. Well, why is this important? Well, a lot of coastal communities around the world take their fresh water from the ground. They drill wells down into the sediment and they extract that water and use it as their source of drinking water. And the problem is that as sea levels rise, as we see over here on the right-hand side of this illustration, you see this dotted line here representing sea level, and you see it's higher than what we have on the left-hand side. So it's illustrating that sea level has risen. Because sea level has risen, there's more force pushing more of that salt water further inland than it was before. And that's represented here by the arrows showing the forcing, and then these dark blue parallel lines showing the zone that has been infiltrated by the salt water. And what we see is essentially that the well that we saw on the left-hand side is now tapping into salt water instead of fresh water. And as I think you know, you can't drink salt water for very long without having lots of health problems associated with destruction to your kidney. And so many coastal communities have been forced to put wells further and further inland as a result of saltwater intrusion here in the southeast and throughout the world. Another form of saltwater intrusion is what happens in our estuaries and our rivers. So first off, what is an estuary? An estuary is the place along the coast where your fresh water that comes out off the landscape, either in rivers or sort of seeping out through the sediments, where that fresh water mingles with the marine water that's very salty, or the salt water. And typically estuaries, you think about typical estuaries along our coast include Mobile Bay, Pensacola Bay, etc. It's a mixture of open water environments as well as marshes and swamps and things like that. Here, I want to specifically focus on rivers and our coastal rivers. Now, salt water is heavier than fresh water, which kind of makes sense because if you're going to dissolve a bunch of salt into water, that water is going to become more dense. It's going to have more mass, more molecules in it. And so salt water, when it comes into contact with fresh water, it tends to sink, and the fresh water tends to be up at near the surface. And what happens on a daily basis as tides along our coast reach high tide levels, you get a wedge of salt water moving up into our estuaries and then backing down again during low tide. In many estuaries, that saltwater wedge can be strong enough that it actually reaches up through the estuaries and into our rivers. Sometimes you get these saltwater wedges moving up dozens and dozens of miles up the rivers near the coast. Some of that is, of course, natural. That's been happening for tens of thousands of years. But the increase in sea level rise that we're seeing is causing there to be greater saltwater wedging, and so that saltwater is reaching further and further inland. It's killing some of the ecosystems along its path because those plants cannot survive in the salt water. But it's also impacting our ability to get access to clean, fresh water for drinking. Some areas along the coast pull their water from rivers for drinking water supply. And if there's salt water coming up those rivers, then they either have to stop the intake of water from the rivers, and because otherwise they would have to extract the salt, or if they do extract this salty water, then they have to extract it in the plant, and of course that is very expensive and causes the cost of drinking water to increase. So some communities along the East Coast, for example, have had to relocate where they take their water out of rivers, going further and further inland because of the saltwater wedging. All of this to illustrate some of the more subtle ways that sea level rise is impacting our access to fresh water, an essential staple for survival, but also impacting our economy and our ecosystems. So now let's take a look at more about these impacts of sea level rise on ecosystems. And in particular, I want to focus on saltwater intrusion and its impacts. For this, I want you to watch a video. It's about what are known as ghost forests. I'll let the video sort of reveal what a ghost forest is. So this is a video made from Time. You may be familiar with the magazine Time. So this is from their website, time.com. So check out this video, and then so go ahead and pause the video right now that you're listening to, and then watch this video. You can access it through the PowerPoint that I've posted in association with this video lecture, or you can get it directly on Moodle. You can find the link that I will have provided for you. And then come back and watch the rest of this section on climate change. Okay, welcome back after watching that video about ghost forests. Some of the key messages there that I want you to get is to understand how our ecosystems are being affected by this salt water. Most plants cannot handle prolonged exposure to salt, and as sea levels rise, our coastal ecosystems are getting increasingly impacted, affected by the rising salt levels in the water. In the groundwater and the occasional storm surges, and causing the die-off of these ecosystems. They're not completely dying off. What you're seeing is a transformation from forest to shrubs and then to marshes. And then, as you saw in the other video about what was happening in southern Louisiana, ultimately those marshes can get swallowed up by open water. And it's that transition that we see happening right now in our southeastern ecosystems. And this has many impacts that we'll be talking about in a little bit later. This is going to end part 3 of our introduction to sea level rise. What we're going to cover next is how are we going to deal with this? What are we going to do in response? And this is when we start to look at some of the really cool ideas that are coming out that are going to be helping us adjust to or adapt to sea level rise and climate change.